Hey guys, how we doing? It's Mr. Chavla, and in this video I'm going to be continuing the part 1 key for the June 2019 Common Core Algebra 2 exam. Now in the previous video I went over numbers 1 through 12, the first half of the part 1 multiple choice questions. Now I'm going to wrap up the multiple choice questions, numbers 13 to 24, all right, the part 1 multiple choice questions. And this is Mr. Chavla or Mr. C. And again, it's the June 2019 exam, number 13 to 24. So let's get started at number 13. A group of students was trying to determine the proportion, that's like saying a percentage or what fraction of the candies in a bag are blue. So they want to determine the proportion of candies in a bag that are blue. The company that makes the candies claims that 24% of the candies in the bags are blue. A simulation was run 100 times with a sample size of 50, based on the premise that 24% of the candies are blue. The approximately normal results of the simulation are shown in the dot plot below. So let's make sure we understand what's being said so far. The students want to know what percentage of the candies in the bags are blue, right? Now, the company that makes the candies said that 24% are blue. The students ran a simulation 100 times. Each of these dots here represents, one dot is one simulation, and there are 100 of them, with sample size 50. So that means there are 50 candies in each bag, according to the simulation. And they did 100 simulations where they tried to get the proportion that are blue when there are 50 candies in each bag, assuming that 24% of the candies are blue, like the company said. And the results of the simulation have an approximately normal distribution, which is this normal distribution curve. All right, so that's all we have so far. And my throat's a little dry. Just gotta let that out. I'm sorry. So they're shown in the dot plot below, where again, one dot is one simulation. Let me move myself down here. The simulation results in a mean proportion of 0.254, which is about 25.4%, which is not that far off from the 24% claim, and a standard deviation of 0.060, which is 6%. Based on the simulation, what is a plausible interval containing the middle 95% of the data? This is actually a simple question, guys. And they gave us more information than we need. In a normal distribution, the middle 95% confidence interval, or the middle 95% of the data, is always going to be the mean, which in this case is 0.254 or 0.254, plus and minus 2 standard deviations, which is 2 times 0.060. Okay, so one of them will be when you do 0.254 minus, and the other will be when you do 0.254 plus, right? So what I'm going to do is going to go into here. I'm going to minimize me for now. So it's 0.254 minus 2 times 0.060, which is 0.134. That's 13.4%. The other one when I add, and I get 0.374. All right? You don't have to put the 0 in front of the decimal if you don't want to, because it doesn't affect the value, right? So the lowest value is 13.4% or 0.134, and the highest is 37.4% or 0.374. So 0.134 to 0.374. That is choice 2. 0.134 to 0.374. All right, so this is just knowing about normal distributions and the 95% confidence interval being within 2 standard deviations of the mean. Okay, now number 14. The selected values for f of x and g of x are shown in the tables below. A solution to the equation f of x equals g of x is, so guys, whenever we have function notation, f of x would have some equation, right? Like, I don't know, like x squared minus 5x, for example, and g of x would have something else, let's say equals 3x plus 1. I'm just making stuff up, right? When you solve that equation, the solution is just the x value, not an ordered pair, because when you're using function notation, the solution to f of x equals g of x has to be the x value that makes them equal. So basically we're saying f of x equals g of x when x equals which number? So 0. F of 0 is negative 6, but g of 0 is 0.58, so this is not a solution. 2.53 is not even in the x column, it's in the y column. So we're not taking f of 2.53 or g of 2.53. This is really saying f of x equals g of x when x equals how much? So x equals 2.53. No, x does not have 2.53, shown. Same thing with 3.01. 3.01 is also in the y column, just like 2.53, but it's not in the x column. So we can't use that as a solution, and by elimination, we have choice 4, but let's just show that it's true. So when x equals 8.52, f of 8.52 is 2.53. G of 8.52 is also 2.53. So when x is 8.52 for both of them, both functions lead to a y value of 2.53. So f of x equals g of x when x equals 8.52. That's right here. Answer is choice 4. All right, so this is just knowing that when you're solving a system of equations using function notation, the solution is the x value that makes them equal, okay? So now we're going to go on to number 15. The expression, and I'll keep myself minimized so that I have room to write. So the expression 6 minus 3x minus 2y squared is equivalent to, so since we have a variable x, I'm going to do this by hand. I'll first write the original expression, where I is the imaginary unit, right? I is equal to the square root of -1, okay? And therefore I square is -1. So what I'm going to do is this becomes, I'll keep bringing down the 6 minus, I'm going to put brackets. I could use the shortcut for multiplying binomials, but in case you didn't know that, I'm multiplying 3x minus 2i by itself. Now what I'm going to do is I'm going to distribute the 3x first, and that'll become 9x squared minus 6xi. Then I'm going to distribute the -2i to get -6xi again, plus 4i squared. And I bring down the 6 minus. Now the next thing I'm going to do before I do anything else, I'm going to combine these like terms to get -12xi. Bring down everything else. The 9x squared will just come down. And I squared, guys, is equal to -1. So it becomes plus 4 times -1. And I'm going to continue simplifying first. So this becomes 9x squared minus 12xi. 4 times -1 is -4. Now, pause the video. I hope I'm not going too fast. I'm going to distribute this negative sign because I could put a 1 and it's the same as multiplying each term in the parentheses by -1. So I get -9x squared plus 12xi. Again, I'm distributing the -1 plus 4. I'll combine the 6 and the 4, which are my two like terms, and put it at the end. And I get -9x squared plus 12xi plus 10. -9x squared plus 12xi plus 10. Which is the first one, -9x squared plus 12xi plus 10. And the answer is choice 1. Choice 2 is out because it starts with positive 9x squared. Choice 3 is just a binomial. And choice 4 is just garbage. All right, so 15 is choice 1. Okay, pause the video if you need to. I'm going to move ahead to number 16 because I'm trying to not to have this video be too long. Uh-oh, I didn't mean to do that. There we go. I'm trying to get the eraser tool. I'm going to erase this, okay, guys? So pause the video if you need to again. Scroll back, do what you got to do. We're going to keep moving. We're going to keep moving. Okay, let's read the next question, and we're making good pace. A number minus, so I'll call the number x, minus 20 times its reciprocal. So guys, let's say I have a number, let's say 3/5. The reciprocal is just what you get when you flip the fraction. You either raise the fraction to the -1 exponent, or you do 1 over the fraction, right? And that'll also give you 5/3. But anyway, if it's a whole number, meaning no decimal, we could just call x is the same as x over 1, right? So its reciprocal will be 1 over x. So a number x minus 20 times its reciprocal, which is 1 over x, equals 8. What is the number? We could either substitute the values by hand. We could use our calculator. So here's what I'll do first. I'll show you guys how to get in the calculator quickly first. All right, I'm going to the decimals graphing calculator, and I'm going to generate a table of values. Or actually, no, I'm going to go to this calculator, and I'm going to go to a table of values. So functions. So one of my function will equal, I'm going to say f of x equals right? I'm going to type in x minus 20 times 1 over x, right? I'm going to type it in just as is. Now I got the function, right? And I want to go to, I want to enter a table of values, right? And I need to set the interval. So let's say we start at -10, end at 10, and just go up by 1 each time, right? So if I look, I want, we should end up with an output of 8, right? -10 gives us -8, if you look carefully, guys. I don't know if it's too visible here. Maybe I'll go to the Desmos graphing calculator. That might be better. So I'm going to set y1 equals x minus 20 times 1 over x. And I want to see which input, x, gives me a value of 8, right? So I'm going to just go straight to the table. X, y1. So which x value, when I substitute for x, results in y1 equals 8, right? So I'm going to just start at -10, and you see -10 gives us -8. So -10 is not a solution because we want it to equal +8. So these two are out, and we're down to 50-50. I'm going to just continue, and you see how when I enter -9, that's not working. None of these values give me +8 so far, but -2 gives me +8. So x equals -2 is a solution, right? So this works. So just by elimination, we know it has to be choice 1 because choice 2 doesn't have -2. But let's get the other values. And you could also type in the values manually. So -2 results in a y value of 8, as we can see right here, right? -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, +10 also results in a y value of 8. So that's how we solve it quickly using the calculator, right? That if I were to substitute x equals 10 into the expression, I would end up getting 8 as my final value. And if I substitute -2, I also get 8 as my value, right? Now, guys, I'm going to do this by hand, okay? So pause the video if you need to. I'm going to show you the same thing. So let's start not over completely, but I'm going to solve this equation by hand. So first thing I'm going to do, guys, if I have x minus 20 times 1 over x, the first thing, if I have x, is going to be replaced with x over 1 because x over 1 is the same as x. I'm going to multiply 20 by 1 to get 20 over x. 20 times 1 over x becomes 20 over x equals 8, which I'll just put over 1. And the fastest way to do this, guys, make all the denominators equal. I see I don't have a 1 in the second fraction, but I don't need it because multiplying by 1 doesn't change the value, and whatever I do to the top, I must do to the bottom. And here I need an x, so I might need to multiply by x in the numerator, and same thing on the other side of the equal sign. Now, since all the denominators are equal to 1x or just x, I just look at the numerators. And in the first term, I get x squared. Bring down the minus sign. 20 times 1 is 20, right? It's all over 1x, but I don't need that, equals 8x, because the numerators are all equal. And by the way, from the original equation that we got where we had x over 1 minus 20 over x equals 8 over 1, we want to make sure this denominator can't be 0 because that would make the fraction undefined. So I also want to make sure I don't get a denominator, a value of 0 as one of my solutions. All right, so x cannot equal 0. If I get 0 as an answer, I eliminate it, which I won't. So now, you could solve this equation quickly by first subtracting 8x on both sides. Since there are no like terms, it's in standard form, it looks like this. Now, this could be solved, it's a quadratic equation that could be solved using either completing the square, the quadratic formula, or factoring. I would recommend either completing the square or factoring because those will be the fastest ways for this. And the better you are at completing the square, the faster that method is, as well as factoring, right? So we want 2 factors of -20. So I'll use the method of factoring. So we know they have to have a sum of 8 and a product of -20, but a sum of -8. So I'm thinking, okay, 10 minus 2 is 8, right? 10 times -2 is -20, but 10 minus 2 would give me +8. So the 10 has to be negative. -10 times 2 is -20, and -10 plus 2 is -8. Once again, -10 times 2 is -20, and -10 plus 2 is -8. So this factors into x minus 10, and x plus 2 equals 0. Now if I solve this, if x minus 10 is 0, I get x equals 10, If x plus 2 is 0, I get x equals negative 2. So the answer should be positive 10 and negative 2, which is right here, choice 1. All right, so it wasn't that bad to do by hand either. 10 and negative 2. And then, of course, you'd want to confirm in your calculator anyway to make sure it satisfies the original equation. But the answers are 10 and negative 2, choice 1. Okay, so number 17, here we come. Okay, a savings account, S, so S is just the amount of money in the savings account, has an initial value of $50. The account grows at a 2% interest rate compounded n times per year, where t is the number of years, according to the function below, right here. So guys, in general, the compound interest formula goes like this. The amount, which usually we use A, but let's say S, after t years, is equal to P, which is the initial value called the principal. T is the number of years, right? 1 plus R over N to the NT. R is the interest rate as a decimal, so P is the initial amount. R is the interest rate as a decimal. N is the number of times compounded per year. I'll just say number of compounds per year. All right, and then T is just the number of years. So if we use this, right, so that's how we got the initial value P equals 50, right? R, 2% as a decimal is 0.02 or 0.02 over N to the NT. So that's how they got that formula, right? So just make sure you understand the compound interest formula. They didn't have to give that to you, but they did, which is very generous of them. Now let's see what the questions are. So which statement about the account is correct, where S of t is the value in dollars, right? So they want to know which one is correct. So let's look at this quickly first. So as the value of n increases, the amount of interest per year decreases. You could use your table to see how this goes, but if you understand compound interest, guys, as n increases, the amount of interest you actually gain per year, that's called the effective interest rate. The amount of interest per year also increases. All right, so this is not true. The more frequently you compound, the greater your actual effective interest rate is called, effective annual rate is called. You earn greater interest per year. And you could confirm that in the table. Now choice 2, as the value of n increases, the value of the account approaches the function S of t equals 50e to the 0.02t. So guys, here's how this goes. Remember, as n increases, the amount of interest per year increases. So if it's compounded annually, once a year, that's called annual, right? That's interest is compounded once per year. If it's, let's say, quarterly, that's 4 times per year. N equals 4. Now if it's compounded, let's say, monthly, let me make this a little neater. So remember, as n increases, the amount of interest per year actually increases. So let's do this. So as for the n value, right? If n equals 1, that's once per year, that's annually, right? It's compounded annually, once per year. If it's compounded, let's say 4 times per year, we call that compounded quarterly. And each time n increases, the amount of interest per year actually increases. Compounded quarterly. If n equals 12, that means it's compounded monthly. That means 12 times a year. Once a month is the same as 12 times a year. Now we could compound more and more frequently, right? There are 365 days in a year. So if it's compounded once a day or daily, that's 365 times in a year. The more frequently you compound it, the greater the interest rate, right? Now we could get to compounding every hour, which would be even more frequently. We could compound to every minute, which would be even more frequently. We could start compounding every second, which will be like a lot, right? But we could go beyond that. The more frequently we compound, what if we compound every half second, every tenth of a second, to eventually we're compounding every single moment in time without a break? That's called compounded continuously, right? So we can't really put an n So as n approaches infinity, we get to what's called, so as the value of n increases to infinity, we get, as it approaches infinity, right? We get to what's called a continuous, compounded continuously. That formula changes to the amount is after t years equals to p times e to the interest rate as a decimal times t power. So since the initial amount is 50, it'll be 50e, and since the interest rate is 2%, that's 0.02 t. So 2% interest starting with $50, 2% interest starting with $50 initially, with continuous compound interest would give us the function s of t equals 50 times e to the 0.02 t, which is, that's what this is saying right here. So as the value of n increases to infinity, the value of the account approaches this function. So choice 2 is our answer because they want which one's correct. Now let's just look at the other ones real quickly. Choice 3 is saying that as the value of n decreases to 1, the amount of interest per year increases. Remember in choice 1, as n increases, the interest per year increases. So as n decreases to 1, the amount of interest per year actually decreases. And then the last one, as the value of n decreases to 1, so if n equals 1, the value of the account approaches this function. If n equals 1, guys, if I substitute 1 for n, it becomes 50 times 1 plus 0.02 over 1 to the 1t. Now, that's if n equals 1, right? If I simplify this, 0.02 over 1 is just 0.02. So this becomes s of t equals 50, 1 plus, again, 0.02 over 1 is just 0.02. And then 1 times t is just t. So it should approach 1 plus 0.02 over t, not 1 minus. So this is out, okay? And our answer is choice 2. There's a website I recommend that does a great job with this. There are a lot of them, but one of them is emathinstruction.com by Kirk Wheeler, right? He has some great lessons. So go to the Common Core Algebra 2 website. And then look up, it's going to be the unit on exponential and logarithmic functions. So exponential and logarithmic functions, right? And then there's a lesson on compound interest. I would navigate the website for you, but I don't know if I'm allowed to do that here. I don't want to like infringe on anyone's copyright. And look for the lesson on compound interest, or just Google eMath instruction compound interest. All right, and you'll learn about everything you need to know. And this question will be like a joke after that lesson, right? That's the best lesson I've ever seen on compound interest. And you'll learn also about what's called the effective interest rate, right? So I won't get into that, but I'd recommend that. Even pause the video, go there. He has some videos that he does for each lesson as well, all right? And it'll help you clarify this if you were not sure, okay? Now let's look at number 18. There are 400 students in the senior class at Oak Creek High School. So there are 400 seniors at Oak Creek High School. All 400 students took the SAT. The distribution of their SATs is approximately normal. Back to normal distribution. The number of students who scored within 2 standard deviations of the mean is approximately, okay, guys, if you remember, when we looked at question 13, 95% of the data lies within 2 standard deviations of the mean, meaning 2 standard deviations below and 2 standard deviations above when we have a normal distribution. So since it's a normal distribution, right, and all 400 students took the test, within 2 standard deviations of the mean, it has to be 95% of the total number of students who took the test, which is 400. So 95% as a decimal is 0.95. So I'm just going to find out what's 400 times 0.95. Or 0.95, and I get 380. So that was a pretty simple question. If you know your normal distribution and the fact that 95% of the data in a normal distribution is within 2 standard deviations of the mean, then this question was very easy. Okay, let's go right ahead to number 19. Whoops, sorry about that. So the solution set for the equation, where this is the equation is, so here's what we'll do. I'm going to do it by hand first, and then I'll show you guys how to do it in the calculator. So the original equation is b is equal to the square root of 2b squared minus 64. Now we need to get rid of the square root sign. To do that, we need to square both sides of the equation, and then the square and the square root cancel out. So b raised to the second power is just b squared. When the square and the square root cancel out, I just write the expression that was originally inside the square root sign without a square root sign, and I get this equation right here. Now what I'm going to do is I'm going to put a 1 in front of this b squared and subtract it on both sides. So I have a quadratic equal to 0. You could have used inverse operations as well. 2b squared minus 1b squared is 1b squared, or just b squared. Bring down the negative 64, you get this. I'm going to rewrite the equation right here as b squared minus 64 equals 0. Now we could have used inverse operations and square roots, add the 64, take square root, but I'll factor this just so we could get the two roots separately. It's a difference of squares, b squared minus 64, that factors into b minus 8 and b plus 8. If I solve for b minus 8 equals 0, I'm going to end up with b equals positive 8. If I solve for b plus 8 equals 0, I'm going to get b equals negative 8. Now, that doesn't mean that this is necessarily the solution, right? If only one of them work, then 3 will not be the solution. 3 is the solution if they both work in the original equation. And if none of them work, then I would pick choice 4, which is saying there's no solution, right? That's saying that it's the empty set. So what I'm going to do now is I have to use the original equation, and I want to find out if substituting, if I call the b value x, right? If substituting an x value into the square root expression gives me back the original x value, right? So let's try this. So one of them is b equals positive 8, right? So I want to take the square root of 2 times x squared minus 64, right? So 2 times 8 squared minus 64. When I substituted 8, it gave me 8, right? So when I substitute 8 for b, in this expression, I ended up getting 8 as my output. So that made this equation true. So that eliminates choice 4 because b equals 8 worked, right? So I'm going to circle the ones that worked. So we're going to eliminate choice 4 because it's not the empty set. Now we just need to see if, and we're going to eliminate choice 1 since that didn't include the positive 8. So it's between 2 and 3. Now I'm going to do the same thing. Now if the equation is true, substituting negative 8 for x instead should have also resulted in negative 8. But it didn't. It gave me positive 8. So the answer is just choice 2. Only positive 8 worked. Negative 8 did not, when I substituted negative 8 for b, it did not give me the same value as the output. So this one is extraneous and we reject. So if we substitute into the original equation, right? Let's go to the smartboard where I have b equals the square root of 2b squared minus 64, right? If I substitute b equals positive 8 into the equation, I end up with 8, where I substitute this 8 for b, equals square root of 2 times 8 squared minus 64. Now I could work this out by hand, but no need. When I entered this expression in the calculator, it gave me 8, so this was true. But when I substitute b equals negative 8, then in the original equation here, it will become negative 8 equals square root of 2 times negative 8 squared minus 64. When I put this whole thing into the calculator, it gave me 8, not negative 8. So this is not true, so we had to reject negative 8, and only this was the solution, okay? And you could have done it by hand as well, but I figured let's do this quickly, all right? So that's the answer to number 19, okay? And I said I'd show you guys how to do it quickly in the calculator as well. So pause the video if you need to, and I'm going to do it in the calculator and show you guys how to get it that way too. So first thing we're going to do is we're going to look at the equation, and we see that the solution sets are either negative 8, positive 8, both positive and negative 8, or nothing, right? So all I'm going to do, guys, is I'm going to go to my Desmos graphing calculator like I did before, right? There are a few ways I could do this quickly. One, clear all this out. One is if I replace the b with x, right? Let's say that I want to find out when is x equal to the square root of 2x squared minus 64, right? So let x equals b. We don't have to say that. basically so that I could enter it in the calculator. I could graph the equations and look for the point of intersection. We have y1 equals x and y2 is equal to this one, right? And I just want the x coordinate of the point of intersection. Actually, better yet, I'll call this one f of x, right? Let f of x just equal x, and g of x equals the square root expression, right? So this is f of x. F of x is your x right here, and g of x is this one right here, all right? So we just want the x value that makes them equal. So I'm going to enter them in the table. I'm just going to use the table, or I could graph them and look for the x coordinate of the point of intersection. So f of x equals x, g of x equals square root of 2x squared minus 64. Now in your calculator, you might not be able to enter f and g. You might have to actually just enter the y1 and y2, which is fine. Let's use a table. And I'll use the same colors we used there, guys. I use yellow for f of x and blue for g of x. So g of x is already blue. Can I change the color here? I guess not. All right, that's fine. F of x and g of x, right? So let's start at negative 10. You see how they don't result in the same value in both columns? Negative 9 doesn't either. See, the f of x, since it's just equal to x, will just be the same value as whatever's in the x column, since f of x is equal to x. See, when I substitute x, f of x gets negative 8, which it should because it's just equal to x, but g of x gave me positive 8, so they weren't the same. So negative 8 is not a solution. So based on the table, I eliminate choice 1 because negative 8 didn't work, and 3 is basically saying 8 and negative 8, but negative 8 didn't work, so I eliminate that. So it's between 2 and 4. Now I'm going to continue and just get the table down, right? Or you could enter the numbers manually, like I could enter 8 here and see that it gives me the same value. It gives me 8 for both. But let's say, I don't know if your calculator allows you to do that, so that's why I'm just going one by one, right? Now, what's going on here? Something just went ARI. Let me refresh. Okay, and I'm just going to use the table again. So f of x is just equal to x. G of x is equal to the square root of 2x squared minus 64. And I want a table, x, f of x, g of x, right? And let's just generate a table from negative 10 to 10. All right, and that'll cover everything. So this, as you see, negative 8 did not result in the same output, so that's out. The other option they gave was positive 8. That resulted in the same output. So we know x equals 8 as a solution from the calculator. So it's not the empty set choice 4, it's answers choice 2. And if you could just type in 8, negative 8, that might be better. So let's just say, like if you're in some calculators, I know you could do in the Casio, you could just type in 8 and then type in negative 8. And you see that you don't get the same answer for negative 8, but you do for 8. And that's a way to do it quickly. Or you could look for the x coordinate where the two graphs intersect. But either way, our answer is choice 2. Enough with this. Okay? Pause the video if you need to. I'm going to move on. So f of x equals g of x when x equals 8. All right? Moving on to number 20. Which table represents an exponential relationship or exponential function? Exponential functions have to increase or decrease by a common ratio as x increases or decreases by a constant amount. So if you look at this one, 1, 2, 3, 4, 5, x just increases by a +1 pattern, right? Which is fine. So then if it's exponential, y should increase or decrease by a common ratio. So we could say it's decreasing. It's being divided by 2. 8 divided by 2, 4. 4 divided by 2, 2. 2 divided by 2, 1. 1 divided by 2, a half. But dividing by 2 is the same as multiplying by a half times a half or times 0.5. So that's exponential because every time x goes up 1, the b or r value is equal to 1/2. That's what we're multiplying by each time, right? I'll call it r for ratio. So that's an exponential function. All right? So answer's choice 1. And we could stop there, but if you wanted to look at the other ones and why they're not exponential, without, again, going into too much detail, this one, the y values are increasing by 1 as x decreases by 4. 8 minus 4, 4. 4 minus 4, 0. Minus 4, negative 4. Minus 4, negative 8. So this has a constant rate of change. So it's linear because the rate of change, remember, is a slope if it doesn't change, and it's the change in y, which is 1, over change in x, which is -4, which you could also rewrite as -1/4. So that's not exponential, right? And for choice 3, if you look carefully, well, one thing is 1 times 4 would give me 4, but 4 times 4 is not 9, and the x values are increasing by 1. If you look carefully, this is just the graph of the table y equals x squared, because 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared 9, 4 squared 16. That's a quadratic, right? That's the parent quadratic function. And if you look at this one, 1 times 8 will give me 8. X is going up by 1 each time. 8 times 8 would have given me 64. The x is going up by 1, 1, 2, 3, 4, 5 in both, and here 0, 1, 2, 3, 4. But it's not multiplying by constant amount. If you were to check this out, this is the graph of y equals x cubed, or the table of y equals x to the third. 1 cubed is 1, 2 cubed is 8, 3 cubed 27, 4 cubed 64, 5 cubed 125. When it's a degree 3, meaning the highest exponent is 3, it's called a cubic function, okay? So our answer is choice 1 for which one's an exponential relationship. And you didn't really need to go through all the other ones. Once you saw that choice 1 was exponential, we could have just picked that one and moved on. So which table best represents an exponential relationship? Choice 1, and let's go. Okay, a sketch of r of x is shown below, where r of x is a function, and it's clearly a polynomial function with 1. I'm looking for how many turning points there are. 1, 2, 3 turning points. So if it's 3 turning points, guys, the degree of the polynomial is always 1 more than the number of turning points. So it should be degree 4. So I'm going to look at the choices. An equation for r of x could be, and we have some choices here. Now if we look, we need to see how many zeros there are, right? So I'll circle those. Zeros are the x-intercepts where r of x equals 0. We have 1, 2, 3. Now, but it has degree 4, right? Then how could it have four factors? Because when we have a, x equals a, it goes right through there. So that just has a root of a as 1 time. So one of the factors will be x minus a. X minus b, it goes right through that. I mean, x equals a, it goes straight through it. X equals negative b, it goes straight through it as well. So that's just going to have x, if x equals negative b is a 0, then x plus b is a factor. All right, this is just using the remainder theorem and the factor theorem, using the zeros to get the factors. Now at negative c, which I'll do in green, it doesn't go through it, it has a turning point there. That means that it has that root twice. So if x equals negative c occurs twice, that means we're going to have x plus c twice. Because if x plus c equals 0, we subtract c on both sides to get x equals negative c. So these are our roots, and this is what our factorization should be, right? So let's see what we got as our choices. In choice 1, we have x minus a, which is good, x plus b, but then x plus c is only raised to the first power. We have to have 2 of them. So we could also rewrite it like this. X minus a, x plus b, x plus c raised to the second power. So if we look at choice 2, I'm looking here, it says x minus c, so that's wrong. This says x minus c, so it has to be choice 4, and let's make sure it matches. X minus a, x plus b, and x plus c squared, and r of x equals that whole thing. So our answer is choice 4, okay? So this is just about knowing how to get the factors based on the x-intercepts of a graph, and understanding that when we have a turning point, at a root, that root is a double root. It happens twice, okay? So moving on to number 22, we're almost there. I would have pulled myself up. Let me put the charger in because I'm running out of battery. I would have pulled myself up so you could see me, but I don't want to block anything, right? I want you to be able to see everything. I have a dry throat. I need to get some water. Okay. The temperature, number 22. The temperature in degrees Fahrenheit. So the temperature is measured in degrees Fahrenheit. So the temperature in degrees Fahrenheit, that was a mess. The temperature in degrees Fahrenheit in Times Square during a day in August can be predicted by the function t of x, where t of x again is the temperature in degrees Fahrenheit, equals 8 sine of 0.3x minus 3 plus 74, where x is the number of hours after midnight, which is 12 a.m. According to this model, the predicted temperature to the nearest degree Fahrenheit. Remember, T of x is in degrees Fahrenheit, so we're going to round to the nearest whole number because it's set to the nearest degree at 7 p.m. is, we need to do two things. First thing, we need to find out how many hours pass because x is the number of hours after midnight. So midnight is 12 a.m. So it's easy to think, okay, 12 to 7, that's 7 hours, but we got to be careful. 12 a.m. is midnight, right? So you go to 1 a.m., 2 a.m., all the way to 7 a.m. in the morning. That's 7 hours. All right? Then, but we've got to go to 7 p.m. You need another 12 hours to go to 7 p.m., right? So the total amount of time passed, we add these two, 7 plus 12 is 19 hours. All right, so I'm going to erase that. Pause the video if you need to, okay? Because I need space to do this now. So x equals 19, because remember, x is the number of hours after midnight. So x equals 19. Now, the temperature in degrees Fahrenheit, okay, is given by this, and x is the number of hours after midnight. According to the model, the predicted temperature to the nearest degree Fahrenheit at 7 p.m. when x equals 19 is, the next thing you want to be careful of, guys, is the first thing is that x has to equal 19, right? The next thing, you want to make sure your calculator is in radian mode, all right? Because if you put it in degree mode, you're not going to get the correct answer. So we want to find t of 19. And I'm just going to enter it in the calculator. We could use the table, or we could put it in here in the scientific calculator. And I want to make sure it's in, see, this is degree mode, this is radian mode. Make sure you know how to, in your calculator, make sure it's in radian mode. And we're just going to enter the equation, but we're going to substitute 19 for x. So 8 sine 0.3 times 19, in parentheses, minus 3 plus 74. And to the nearest degree Fahrenheit, we're going to round to one decimal place. I'm sorry, to the nearest whole number. 77.419, which, because of the 77.4, will round down to 77 degrees Fahrenheit. All right, so to the nearest degree Fahrenheit, at 7 p.m., the temperature will be about 77 degrees Fahrenheit, choice 3. Okay, we're almost done, guys. I hope this isn't going on too long. Again, pause the video if you need to. Again, and I'm not going to be showing myself because I need space to be able to show the work here, all right? Now consider the system of equations below. Which number is not the value of any variable in the solution of the system? So they want to know which value, this system of 3 linear equations and 3 variables, which one's not the value of any variable in the solution, which one is not a value of any variable in the solution of the system. So I'm going to do it first in the calculator, right? If you use the Casio Advanced Graphing Calculator, you would go to Matrix Simultaneous Equation Solver, but I don't have that on the computer, right? I don't know if or how you would do it in the TI, but I found a cool calculator online, the numwork. So what I'm going to do first is I'm going to refresh this page. And this is a free online calculator. I love the Desmos graphing calculator as well as the Desmos scientific, but I don't know if or how to solve the system of linear equations in that, especially with 3 variables. So what I'm going to do here is, this is called numworks, right? So if you just Google that, numworks graphing calculator, you could get it too. It's for free. Don't have to download anything. But I'm going to go down to equations right here. And you could use your keyboard, right, on the computer. And I'm just going to click enter on add equation. And I'm just going to click enter for empty so I could type the equation in. So unlike a Casio in which you would enter the coefficients into a matrix, you have to type in the whole equation here. So x plus y minus z equals 6. Enter the equation, hit execute. Then go down and click add equation again. And then click on empty so you could just type in the equation. The next one, 2x minus 3y plus 2z equals negative 19. So I just type that in, hit enter, then scroll down to add equation, and then I again hit on enter on empty and enter the last equation. Negative x plus 4y minus z equals 17. I hit enter again. Now it has a system. The calculator recognizes it's a system. I'm not going to add another equation. I scroll down, hit solve the system, and I get the 3 values. X equals negative 1, y equals 3, z equals negative 4. So x equals negative 1. That's right here. Y equals 3. And z equals negative 4. And they said which number is not the value of any variable in the solution of the system. This is x. 2 was not a solution to any of them, right? So that's how you do it quickly in the calculator, okay? It could have been done by hand. I hope that your calculator allows you to do the system of equation solver and that you know how to use it, right? And in a minute, I'm going to go over how to do it by hand, okay? For choice 3, y was equal to 3, and z was equal to -4 for choice 4. So which one's not the value of any variable? Choice 2, the number 2, okay? Now I'm going to do this by hand, okay? So pause the video if you need to, and I'm going to just erase everything and show you guys how this can also be done relatively quickly by hand as well, okay? In case you wanted to do it that way, or you don't know how to do it in the calculator, or maybe your calculator doesn't allow you to do that, which is not cool if that's the case. I like to label each equation. So I'll call the first one A, second one B, and the third one C, just so that we know which one I'm referring to. So if you look at A, we have positive x, and at C we have negative x. So if I add equation A, x plus y minus z equals 6, to equation C, which is negative x, or negative 1x, plus 4y minus z equals 17, x minus x cancels out if I just add the equations down. This is the same as 1y plus 4y is 5y. I could put a 1 in front of this, and negative 1z minus 1z is negative 2z. And then I add the 17 to 6 to get 23. So bring down the equal sign, right? And typically we end up using elimination to eliminate one of the variables. Then we end up with a 2 by 2 system, which means 2 linear equations with 2 variables that I solve again by elimination like we did in Algebra 1, right? But in this one, you're going to see something interesting happens. Now I'm going to use B. So equation B, I'll write it in red here, was 2x minus 3y plus 2z equals negative 19. Now here's what's happening. Equation C, if I want to combine it, I'm going to use equation C because it has the opposite sign on the x value. I can't just combine as is. I need to multiply each term by positive 2, which if I do that, I get negative 2x. So 2c, we know what it is, right? It'll become negative 2x plus 8y minus 2z equals, remember, we got to multiply the 17 by 2 as well, and we get 34, right? Now, the goal is, as long as we eliminate one of the variables and the x, right, we would have a 2 by 2, which we know how to solve from algebra. But if you look here, 2z minus 2z is also 0, so that's even better. Negative 3y plus 8y becomes 5y, and negative 19 plus 34 is 15. Divide both sides by 5 and you get y equals 3. So which number is not the value of any variable in the solution to the system? Well, y equals 3, right? So that's out. This one is a value of a variable. Now, if I substitute into this equation, if I substitute 3 for y, minus 2z equals 23, 5 times 3 is 15, minus 2z equals 23. Subtract 15 on both sides, and you end up with negative 2z equals 23 minus 15, which is 8. Divide both sides by negative 2, and you get z equals negative 4. So we got this and this. This is our z value, right? So that's also eliminated. Then I'll just look at the original equation, x plus y minus z equals 6. So I'm going to substitute the numbers, so we don't need the a, b, c here anymore, right? So you could have used either one of the equations, but I figured the first one is the easiest. So x plus y, which is equal to 3. Now we got to be careful here. Minus z, where z is negative 4, equals 6. Minus negative 4 is the same as saying plus 4, and positive 3 plus 4 is 7. So we get x plus 7 equals 6. Subtract 7 on both sides, and you end up with x equals negative 1. So that eliminates choice 1. Only choice 2, the number 2, is not a value of any of the variables in the solution set of the system, okay? So that was by hand, not that bad either. If you know how to do it, it's not that bad, all right? One more question, number 24, okay? Pause the video if you need to. I'm going to scroll right down. And I'm going to erase some stuff here. Okay, so number 24, the last one in the multiple choice section. Cameron puts $400 into a savings account that earns 6% annually. That means 6% per year. Annual means once a year. The amount in her account can be modeled by C of t. They use C for Cameron. So C of t is the amount, equals 400 times 1.06 to the t power, where t is the time in years. Which expression best approximates the amount of money in our account using a weekly growth rate? Okay, so this one's tricky at first, but once you get the hang of it, guys, this is actually, this question becomes a giveaway if you know what you're doing. Um, and I could go into more detail with this. So if you don't understand my explanation, I could actually go into detail with this and show you guys how to do this in more detail, but I don't want to spend too much time. First thing, they did not have to give us the equation. The amount after t years, remember exponential growth. You start with $400, Cameron does anyway, and it's 1 plus 6%, which as a decimal is 0.06. 1 plus 0.06 is 1.06 to the number of years, exponential growth, t power, 6% per year, right? So now, the next thing, guys, we want to rewrite this equation using the weekly growth rate. So here's how it's going to look like. You want to use the fact, and you want to memorize this. Just like there are 12 months in a year, there are also 52 weeks approximately in a year. It's a little bit more. 52 weeks make 1 year. But then the question is, what about, how would I get this to be 1 week, right? If I divide by 52, 1 week is equal to 1 over 52 years, all right, which is less than a year, and that makes sense because 52 of the weeks makes a year. So if I wanted to raise, let's say, if I wanted to, in 1 year, I would just multiply 1.06, not multiply, I would raise 1.06 to the first power. That'll be 400 times 1.06. In 5 years, it'll be 400 times 1.06 to the fifth power, right? In my internet just died, not died, but like shut off. Let me just reboot it. Okay, in 10 years, which is a decade, I would raise 1.06 to the 10th power, right? So these are all quantities higher than a year. But let's say 6 months, right? 6 months is the same as half a year, 6 out of 12. I would raise 1.06, so if it was 6 months, that's equal to 6 over 12, or 1/2 a year. I would want to do c of a half is equal to 400 times 1.06 to the 1/2, or 6 over 12, right? And in 1 month is 1/12 of a year, I would raise to the 1/12 power. So each week, guys, I have to raise, because in 2 years, I would raise 1.06 to the second power. In a week, which is 1 over 52 years, I would raise, let's look at just the exponents for now, okay? 1.06 will be raised to the 1 over 52 power each week. So this is our weekly growth factor, what we multiply by each week. Weekly growth factor or weekly multiplier. And it should be smaller than the yearly one. So the equation would end up looking like this. C of t equals 400 times 1.06 to the 1 over 52, and then we have the t in the exponent for years, right? Now here's the problem, guys. We're using C of t. C of t is just one function. The equation should not be any different from this. It should be equivalent, and it should approximate. So if I have a growth factor of 1.06 to the 1 over 52, that's not going to cut it, because it should still give me 1.06 to the t, where t is the number of years. So to undo the fact that I raised over 1 over 52 to get the weekly growth rate, remember I multiply exponents when I raise a power to a power. So if I have a 52 on top, 1 over 52 times 52 is 1. So this is the same as 1.06 to the t. Now all I have to do is find out what 1.06 to the 1 over 52 is. And that's about 1.0011211184. So in terms of the weekly growth rate, and the only reason I remember this, guys, is not that I remember it, is that one of the choices has those numbers too. So this is in terms of the weekly growth rate, where if we have, because if I raise this weekly factor, this is for per week, right? So to get for years, each year, this has to be raised to the 52nd power. So this is the weekly growth rate to the 52nd power would have given me the yearly growth rate, about 1.06. So this is how it would look like. So that's choice 4, all right? If you look at choice 3, it has the wrong factor here. I don't have any clue how they got it. Choice 1, look, if they did not change the variable t, and you have 400 times a different number than 1.06 just to the t power, that's wrong because it's not the same function, right? We're still using t for years, okay? So that's how it would go. Now I'm going to show you guys how to do this quickly, all right? So I'm going to go to the smartboard, and let's get this really quickly. And I'm going to show you guys what this would look like. So we start off with C of t is equal to 400 times 1.06 to the t, where t equals the number of years, right? In a month, if I want it in terms of the monthly rate, right? A month is less than a year, so I'm not going to raise to the 12th power. I'm going to raise 1.06 to the 1/12th power, right? But if I still want to keep it in terms of years, 1/12 needs to be raised back to the 12th power. So C of t would equal 400 times this value. So if I'm writing in terms of the monthly growth rate, right, it'll be to the 1 over 12, and it's 1.0048, all that stuff right there, 4867551. So it's 1.004867 551. And this is the monthly growth rate, right? But since they're 12 months in a year, or monthly growth factor, they're 12 months in a year, that's why it has to be raised back to 12 each year. So this would be in terms of the monthly growth rate, right? There are 52 weeks in a year, so I follow the same principle. So a week is less than a year, so it's not going to be to the 52nd power, it'll be to the 1 over 52, right, each week. But since there are 52 in a year, and I need these to cancel out, I need 52t here. So the expression or equation would look like this, and then this 1.06 to the 1 over 52, right, if I change this, is 1.011211184. What was it? 1.0011 21184. Wow, I actually got it. So this is per week, but they're 52 in a year, so the weekly growth rate has to be, or weekly growth factor has to be raised to the 52 each year. So using either exponent properties or the fact of this, like how the situation works out, right? We would get that equation with the weekly growth rate, right? So if you experiment with that, if you need more, like if you have more questions, guys, I'll gladly go over it, but that's how we got it quickly, all right? Now we're gonna move on. No, we're not moving on. That was it, guys. So let me come say goodbye and wish you luck. All right, guys, so thanks so much for coming by. I wish you nothing but the best. Let me see if I can. Sorry. Okay, thanks so much for coming by. And I hope that you found this useful. If you did, please hit like and subscribe, and refer your friends if you think they would benefit from it. And please, if you have any questions, let me know in the comment section below. I'll be checking it out, and I'll be glad to help you out. And if there's anything I could help you with, any comments, anything you'd like me to do differently, any way I could improve, I'm more than open to your feedback. All right. Thanks so much, guys, and I wish you the best of luck. If you're taking the Regents soon, study hard, but please don't stress. You're more than capable. All right. Believe in yourself. Do the best you can. All right. Bye for now. Take care.